Hi, this is Lonnie with MainPC.com. Today we're going to be hacking the TowerPro MG995 Servo. It's a sub $10 servo from eBay.com. And we'll get right into the parts and tools we're going to need. First, we're going to need a servo, MG995 Servo. We're going to need Needlenose pliers and dikes, two 2.2K ohm resistors. You're going to need a phillips head screwdriver small enough to open these 4 captive screws on your servo, and we're going to need a couple of assorted flathead screwdrivers, which I'll show you in a little while. A little bit of electrical tape, soldering iron, 60/40 solder, or whatever kind of electronic solder you like. This is I believe this is actually still lead. This is lead solder. A lot of people are going with lead free now. And then a sponge. That's all you're going to need. Okay, first thing we're going to have to do is open up our servo. Okay, get on tight on the servo. You good? Okay, I'm just going to undo these 4 screws. And not all servos are the same. Some will have, this is a metal gear servo, and all the servos are going to be a little different, but these same principles that I'm using to hack this servo for continuous rotation will apply to all servos. You're going to have to somehow disconnect the potentiometer and then replace it with a couple of center tapped 2.2K ohm resistors. That's always going to be the same. What's going to be different sometimes is there's going to be different stoppers or whatnot you're going to have to cut out. In our case, it's going to be a pin we pull out because we're dealing with metal gears. If you have a plastic one, you're probably just going to have to X-Acto knife out a little plastic stopper or something to that effect. Okay, and you want to be real careful with how you take this off. This is taking this off. You'll see. You can take the cover all the way off, and we're on the back side here. You get a nice tight shot of that. You can see it good. And you can see that once we open it up, we have, this is the actual, right here's the motor, and inside of there is a potentiometer, and this is a little circuit board here, and the potentiometer is what we're going to be disconnecting. We're going to be desoldering these 3 white leads here and replacing that with a resistor. One side resistor, one resistor here, one side the other resistor here, and the center common center tap is going to be right here in the middle. So before you get started too, if you have any of these control horns on your servo, you can go ahead and pull them off. Okay, we're going to start with the gears. Carefully take the gear side the case off. And you want to go ahead and get a nice tight shot of this. Take it for a second, because I'm going to take and put a still up.
Okay.
Okay. And that's be a good idea for you guys, is to take a quick picture of the gears, just so you can remember how to put it back together. If you forget, you can look at your picture, because we're going to have to take it all the way apart. And there's a lot of grease on here, so go ahead and get you some paper towels and napkins and stuff. And you want to make sure you don't get the gears dirty while you're working with it. And also on the MG995, if you look, get a tight shot right here. There's a little bearing pack right here. Sometimes that'll come out and it'll stick like right here. So if it does, or it'll just fall out, that's where it goes, and that's the orientation it goes in. Okay, so we're going to take this apart, and you'll see one of the things is keeping us from turning full rotation. Sarah, can you see this pin right here? Point to him with the screwdriver. Might be kind of hard to see, but you'll see a little pin sticking up, and that's actually going to interact with. There's a couple of plastic stops in here, and when that pin hits the stops, it stops it from going all the way around. So what we're going to do is You can do one of two things. You can either hollow out that plastic, which would be a pain in the butt, or you could come in here, take this gear off, and we're going to hold the gear with our needle nose. And this worked fine the other day. Hopefully it won't fail me now. Hold it tightly with the needle nose. You're going to take your cutters, your side cutters, try and get all the way on the base of that pin. And just kind of pry it out. And just hold it real tight and pry it out. And you'll see I have the pin right here. So that pin's out. And you can throw it away or whatever. We're not going to be using it again. So these other gears, good to go here. So take that all the way out. Okay, now if you look, there's another key part. So try and get a nice close-up, Sarah, so we can I can make a nice still picture. You see the inside? And if you look at the inside there, you'll see a little like a rectangular notch. That's what we're going to have to eliminate, because that notch, this right here, this fits into that notch. This is the back side of the potentiometer. So it's real hard. This potentiometer is real gunked up and stuck inside of the servo case. So instead of taking the potentiometer out, we're going to, this is just plastic, we're just going to hollow this plastic out to where it's smooth and the potentiometer control won't even touch it anymore. So that's why we have these screwdrivers here. I'm going to start, just going to put it in there and just start twisting. And I'm going to hold this with the needle nose to keep it steady. If I just start twisting, tearing up that plastic, it's going to get it out of there pretty quickly. It's not very hard. And if you pull it just right, you can remove, there it comes now. If you look at this, whoops, so actually just pull the little plastic piece out. That's what you want to do. The more of that you can get out in one piece, the cleaner it'll be, because you do have some little ball bearing pack right here to worry about. So you don't want to get that too dirty. If you look inside there now, get a nice close-up, you'll see the little rectangular plastic thing is like completely gone. So we're actually done with this complete side of the servo, so I'm just going to put it back together, which will just be putting this down on top, and now it's not even touching the potentiometer at all. You can see it's already spinning all the way around, and then we're going to put this here. Wait, something's missing. Something's upside down. Upside down. And I almost forgot already. Okay. And I found whenever the top's not on it that the gears won't really spin well, because they're not held together. There's a little this kind of holds the gears together. So don't try and spin them. I think you're just gonna risk stripping your gears out. So I'll actually just go ahead and put this back on. Wait, is that the right side? No, this side. I'm actually just going to go ahead and put this back on loosely. Not going to screw it down or anything, but we're done with the gear side, so that was very easy. Now this is where we're going to come in and do a little soldering here. Like I said, we're going to take these 3 wires here, these little white wires, and we're going to desolder them. And really what you could do, if you want, make it a little easier, is you can just go ahead and cut them. And they're attached in here. You can either cut them from off of there, or you can desolder them. It doesn't matter, or you can like yank them. Because you see there's 3 pins coming up off that potentiometer. What you can do is just yeah, you pull them off easy enough. Just say pull them off. almost cursed on my video, but I didn't. Okay. Put that back on there. Oops, I got some stray wires. That's why it's good to unsolder them, I guess.
Yep.
And okay, and then you'll have 3 pins sticking up off the potentiometer. You just go ahead and bend those down if you want to, just to make a little room for our resistors that are coming in. You get a tight, can you see the pins? There's 1, 2, 3 pins coming up off of this potentiometer. I'm just going to bend them down just to give us plenty of room for our resistors. Can you see that?
Mm-hmm.
Okay.
It's actually kind of shadowing, the side is shadowing off so we can't really see it.
Okay, well, anyway, I just bent those 3 potentiometer pins down. That's all I did. Now we're going to take our 2.2 k ohm resistors. And the idea behind the 2.2 k ohm resistors is we're going to give, we have to fool the little logic board into thinking we still have the potentiometer in there. And we want it 2.2K happens to be approximately half of your of a 5K potentiometer, which is what we just disconnected. So I guess really 2.2 no, that's not actually, that's wrong. That's inaccurate. Cut. Okay, now we have our 2.2 kilo ohm resistors, and first we need to twist them together. Okay, and I've just made like a twist up top. Can you see that? With 2 of the legs. And then I'm going to take one of the legs and I'm going to bend it downwards to where it's like that. Okay. Then we're going to take the other legs, we're going to bend them down too. So it's going to end up looking a little bit like a, I guess like a trident, like that. Okay. And first thing we're going to do is we're going to go ahead and hook it up to our little helping hands. Get your soldering iron. Mine's been heating up for about a half hour now, so I'll be good and hot. And get it nice and tight on right here. Okay. And we're just going to heat this joint up and put some solder in it up top. And this is some really easy soldering. It doesn't have to, not very exact at all. So that's done, and after we do that, go ahead and cut a little excess lead away. Let it cool for a second. And there, now we're left with that. And that is what's going to be hooking up right here to replace that. There's 3 wires. Okay, but we're going to go ahead and prepare it a little more by trimming it up some. We're not going to have a whole heck of a lot of room to work in here. So now, series, you get in tight on this. I'm going to hold it with these so you can see the whole thing. Nice and tight. That's what it's going to look like after we've soldered the 2 resistors together. Got it? Okay. And then what I'm going to do, since it's going to go, you can see it's going to actually mount like this. So what we want to do is it's going to get soldered like this. So we want to kind of make some pads for it. So what I like to do is kind of bend the very end of these out a little bit to give me something to, like a little solder pad to work with. Nice flat surface. Okay, and then it'll go just like that, and I can bend it down easy because we're going to tape it up after we're all done. So first thing we need to do is I'm just going to come in nice and tight on these little 3 wires, Sarah. Ready? Okay. I'm going to remove the old stuff. Just going to hit the little ball of solder real quick. Comes right off. And if you look, still got some nice globs of solder on this board. Probably just going to reuse it. Not always a real great suggestion, but I think in this case it is a pretty good idea. You see, we want to kind of eyeball your spacing a little bit. If you want to, you can add a little more solder. If you have enough, just use it though. Come in. You got good lighting and everything, Sarah? Mm-hmm. We're good? Okay. And you just heat that little ball up. As soon as it's a little porous. Or is it behind this box too much? There. That might be better, huh?
Hold on, I think I need to hand hold this one.
I think you should too. Okay, get positive control over that lead and heat the solder up. If you can heat the lead and the solder up at the same time, you get a much better joint. It looks like I might need a little more solder on that joint. I'm going to add some in just a second after I finish this last lead. And if you need to, you can use your, go ahead and use them now. Use your helping hands to kind of hold it up for you. Let you come around over here, Sarah's. Over here behind me. I'm going to be soldering right here. Okay. Okay. And it looks like they're all 3 on there good. Got a good shot of that finished product. Finish soldering job. Okay. Alright, and okay, so we've got our 3 resistors on, and now all we're going to do, if you look in here, we're going to be mounting this back in like this, and I really don't want to do anything to these resistors, so I'm going to wrap a little bit of electrical tape around this, and you also want to make sure that your resistor leads aren't touching any components on your little circuit board, which I made sure they're not, and they won't, because the resistors themselves are going to block it. You can just wrap this whole little board in some electrical tape. That'll keep anything from shorting out later.
So you're positive we don't need to do anything else with this board?
Right. Okay, and we're going to put our motor. And you can see down there, you see where it's interacting. This motor is going to interact with that gear in there. Okay. With the electrical tape it is going to be a little tight, but that'll be okay. I need to make sure I have that gear mounted in the motor good.
So can it now turn 360 degrees?
I don't know, we're gonna have to test it. But first, we're just gonna close this back up. Like I said, it was a little tight with that electrical tape in there. Oh wait, plus I have it backwards. Oh, that's upside down too. That would help. Okay. It's going to close up good. Make sure you stab yourself at least twice while you're closing it back up. Okay, so now we're all closed back up. I'll reattach the little control horn. And you can see I can manually turn it all the way.
Wow.
Because we're not attached to the potentiometer. And we took the little metal pin out of the gears. So
Good for you.
okay, now that we hopefully got our servo hacked up, now we need to test it. So
Yay.
here's where I found the code at. Just go to arduino.cc reference, and we're going to look at the libraries and servo. And they actually have, let's see, servo, right? Here's some example code right here. There's a complete little program. And all this little piece of code does is it centers your servo by doing myservo.write90. It's supposed to set the servo to the midpoint. If it still had the potentiometer in it, it would. The way we're using it, 90 should hopefully be stop, and then 180 will be full rotation in one direction, and 0 will be full rotation in the other direction. And the closer you get to 90 from either one of those, the slower the servo is going to go. So you actually have speed control like that. So we're going to go ahead and copy this code, and we'll open up our Arduino program. Paste. Make sure my board's all set up. Not. Need to put it on Uno. COM3. And I'll go ahead and upload my code. Okay, it says it's successfully uploaded. So that's not really what we wanted to do though, because this is going to just center it. But I'll go ahead and show you how to hook up the servo now. Can you swing over here, Sarah? Okay, and a lot of you guys probably already know this. I got 3 jumper wires here, and all I'm going to do is connect these jumper wires into the to the little connector here on the servo. And you have, on this kind of servo, you've got orange, red, and brown. The red is the power, the brown is the ground, and the orange is the control lead. So the control lead, in this case we're using pin 9 on the Arduino, so we're going to put one jumper inside of the connector, and the other jumper we're going to put into digital pin 9 on our microprocessor, and then we're going to put the hot, or positive, we're going to just put that to the 5-volt lead, and we'll put the ground to ground. Okay, now, alright, you can see the servo is turning, and it's not supposed to be turning.
Why?
So this is what we have to do now. And this is one of the things with these cheap servos. I think it probably has either something to do with the servos, or we're using 5% resistors. So it's also probably like a disparity in the resistors, an imbalance. If you use like the 0.1% resistors, this might not happen. So what you have to do with each one of these servos, if you go back over the screen here, I'm going to just try different values. Like I'm going to try 95 and upload that code. And let's see if okay, it's slower, but I don't know what, let's see what happens if I do go 100 here. Okay, now it's really slow, so I might have passed it. So you see what I'm doing is I'm just, your stop is going to be somewhere around 90, 102, let's see, 104. Still just barely moving. So it's a pretty good bit out of tolerance. Let's see, it's on 105 now.
It moved.
You try re-uploading that. Okay, it looks like we're at a dead stop here at 105. Okay? So we know now for this servo, for this particular servo, you're going to have to do this for each one. 105 is our midpoint, is our stop point. Okay? So now, if you go 180 and then upload that code, now here's where you're going to see full rotation. That's full rotation, looks like it's going counterclockwise for 180. And stay on the servo, and all I'm going to do is I'm going to change my servo.write to 0. Stay on the servo, and we should start going clockwise. So 0 is full speed clockwise, and 180 is full speed counterclockwise, and we know for this particular servo that the midpoint is 105 for stop. And anywhere in between, you can make your servo go different speeds. If you're using this to drive a robot, then you're also going to have to calibrate your two servos at full speed. Like one of them you might, if you want to go full speed, one of them might run on 180 and the other servo might be a little too fast, so you might have to run it at 177, for straight travel. But that's just the nature of an analog device like a motor. So that is the end of hacking the MG995 servo. Thanks for watching. Bye-bye.